All right, today's lesson is on asymptotes. The asymptotes are these lines that are going to bound the hyperbola. So if I were to draw the hyperbola, first we're going to go in the horizontal one. So this hyperbola is going to come out this way and touch those asymptote lines. So what I'm looking at is the equation of the line that passes through the center. And what I know about slope is that it's rise over run. Now, to get to this corner, which those asymptote lines go through, I know that if I go up B units and over A units, that's going to be the slope of that line. So this is going to be point slope form of the equation. Usually we use slope intercept, but this is going to be point slope. So I know if it goes through HK, the slope is going to be B over A, rise over run. So in a horizontal hyperbola, this is the equation. It's plus or minus. Notice I have one that's a positive slope, one that's a negative slope. In the vertical one, the hyperbola is going to open up and down. So if I take a look at that, the only thing that changes between the vertical hyperbola and the horizontal hyperbola is that A is going to be the distance between a center and a major, and B is going to be the distance between a center and a minor. So that slope is going to be A over B. And then so this is the positive one, and this is the negative one. So the only thing that changes is this is going to be y minus k equals plus or minus A over B instead of B over A. We're going to do a couple examples. So this is the first one. It is x minus 3 squared over 16 minus y plus 4 squared over 36 equals 1. I'm going to move the camera. So I know this is going to be a horizontal hyperbola. So to build those asymptote lines, I'm going to do y plus 4. I'm just bringing down this quantity, not the squared, equals plus or minus, since this is horizontal, it's going to be b over a, so 6 over 4. Then it's going to be the x minus 3. Now, I can't distribute a plus or minus at the same time, so what I'm going to do is I'm going to break these up into two separate asymptote lines. So I'm going to have y plus 4 equals, I'm going to reduce this fraction to 3 halves, x minus 3. So I'm going to have two different asymptote lines. Next thing I'm going to do is I'm going to distribute this 3 halves. Then I'm going to subtract 8 halves to both sides. Just so I can make sure that I am going to get common denominators. So the first asymptote line is y equals 3 halves x minus 17 halves. And in this one, I'm going to distribute the negative 3 halves. So y plus 4 equals negative 3 halves x plus 9 halves. And just like the last time, I'm going to subtract 8 halves. That's going to be plus a positive 1 half. So these are those two asymptote lines. So if I were to graph it, I'm going to sketch this out pretty quick. Center is going to be 3, negative 4. This is going to be horizontal, so it's going to open to the left and the right. A is going to be 4 units, so I would go 4 units each way. Uh, 6 units up and down. Remember, in the hyperbola, it doesn't matter which one is larger, A or B. I just know C is larger. The largest, I should say. There's my central rectangle. Now, when I build these equations, this is going to be the positive one. And then, that was a terrible line, but it should cross here at negative 17 halves. Then the other one should cross at a positive 1 half. You should see my hyperbola isn't drawn to scale, but it should look somewhat fine. And then that hyperbola is going to approach those asymptote lines, opening to the left and to the right. Now, in a normal year, we would graph this in a calculator. So what I'm going to do is I will show that in class. But what I'm going to do is our calculators are set equal to y. So that's why I solved these both for y equals, so I can quickly plug them into a calculator. The next thing I'm going to do is I'm going to solve this equation for y, just so I can plug everything into my calculator. So I'm going to pull this to the side. First thing I'm going to do is I'm going to move this whole fraction to the other side. So I'm going to have negative y plus 4 squared over 36 equals 1 minus that whole quantity. Next thing I'm going to do is I'm going to get rid of both the 36 and the negative. So I'm going to multiply both sides by negative 36. It's going to cancel the 36 out and the negative. So I'm going to have y plus 4 squared equals negative 36 times 1 minus x minus 3 squared over 16. Next thing I'm going to do is I'm going to have to take the square root. Remember, plus or minus. Now, a lot of people have an issue because they think that because this is going to be negative, it's going to turn everything into the radical sign negative. But that is untrue. I know these x values between, I think, like negative 1 and positive 6 would make that negative, because it's not, that hyperbola is not going to be defined here. So once it's on either side of that, it is going to make that positive, because once I distribute that. But we're just going to leave it like that so we can plug it into the calculator. Then I'm going to take the 4 to the other side by subtracting it. And then we're going to plug that into our calculator very carefully. Now, if you do have a TI-83, you are going to have to put a parenthesis here, and then you are going to have to open a double parenthesis here, just because we want to make this whole fraction before we subtract the 1. So if I were to plug that into my calculator, a TI-83, anything higher than that, you can use a fraction bar and make it easier. So we are going to have to put 2 in because your calculator can't recognize a plus and minus at the same time. So we're going to have to put 2 separate equations in there. So it'll be y equals negative 4 plus the square root. I'm just going to open the square root of 36, negative 36, 1 minus double parenthesis x minus 3 squared over 16 and the parenthesis. So that's what it should look like once we're going to plug it into our calculator. I am going to do a vertical. So I'm going to have y minus 3 squared over 100 minus x minus, actually I'm going to put a 20. let's put 25 in. Not there. All right. So I have y minus 3 squared over 25 minus x minus 2 squared over 9. So since this is vertical, I know this A is going to be 25, B is going to be, A is going to be 5, B is going to be 3. So when I build that equation of the asymptote lines, I'm going to have y minus 3 equals x minus 2. Actually, I need to do the slope first. So that's going to be plus or minus A over B, so 5 over 3. Split it into two separate equations. Y minus 3 equals 5/3 x minus 2. Y minus 3 equals negative 5/3 x minus 2. I'm going to distribute. Should be 10/3. And then I'm going to add 3 to both sides. So I'm going to add 9/3. So I should have y equals 5/3 x minus 1/3. And y equals negative 5/3 x plus 19/3. So these are the two asymptote lines we would graph for that function, that equation I should say. The next thing I'm going to do is I'm going to solve it for y. So I'm going to take this to the other side. So I'm going to have y minus 3 squared over 25 equals 1 minus that whole fraction. Multiply by 25. Take the square root and add 3 to both sides. Kind of doing two steps in one. And that's it.